Fine. So fill this Butterworth table like that. 1.8476s plus 1. Okay. You can do this. Okay. For n equal to 5, it is s plus 1 into s square plus 0.6180s plus 1 into s square plus 1.618s plus 1. See, one thing you need to remember is what happened. Okay.
Mom, I wanted to ask something, mom.
Okay. So, all right. So, I think my voice is getting echoed because in your device.
Mom, excuse me, mom. Can you hear me, mom?
Yes, yes.
Ma'am, actually, I wanted to ask you something, ma'am. So, we have found out for B2 of S now, ma'am. The same way, if you want to find it for B3 of S, it will be like S minus S naught into S minus S1 into S minus S2, ma'am.
Correct, correct, correct.
Okay, ma'am. Thank you, ma'am.
Okay. Similarly, for S4, it is S0, S1, S2, and S3. All these are the poles which will lie on left half of S plane. Okay. You try it out. Try it out, everyone, and you should be able to get this. One more important thing to remember is the order of the filter. See, the order of the filter here is 2, and the degree of the polynomial, denominator polynomial is 2. See, the order of the filter is 3, right? Are you getting what I'm telling? Order of the filter is 3, and the degree 2 plus this 1 degree is 3, right? The order of the filter is 4, the degree of the denominator is 4. S square, the highest power will be 4. So always remember this, okay? Maybe when you solve, you will get the expanded version. You may write it as s power 4 plus something. It's okay. You can expand and write it, or you can keep it like this, in this form. So these values, at least for order till order 5, if you can remember, it is okay. Or else you can always, if you remember how to do it, like I showed you here, you can easily do it. 1 by product of all these values, you can easily always get it. Okay, for n equal to 2, n equal to 3, always you can get it, get these values. Okay. So this is about how we are going to get the order of the filter. All right. So now I will tell you there is something called as analog to analog transformation. So if I tell you, like if I can actually give you the table. Okay, let me not waste time writing that. Okay, I'll send it. I think it's there in the notes also. I'll have a look and I'll just give it to you. I will send it to you. Okay, that is what should happen. Now what we have designed is nothing but your low pass filter. Whatever we have designed, the low pass filter with omega c is equal to 1 radians per second. 1 radian per second. So this is nothing but your normalized low pass filter. Now suppose the given value, the given specification is that of a high pass filter. What will you do? If it's a band pass filter, what will you do? If it's a band stop filter, what will you do? So these are the questions. And even if it is low pass filter of some other cutoff frequency, say it is given 2 radians per second, what will you do? So the transformation that you will be doing is nothing but a low pass to low pass transformation. Okay, in the first case. Okay, in the high pass case, you will do low pass to high pass transformation, or you can do low pass to band pass transformation, or you can do low pass to band stop transformations. So what is the meaning of this? Since you have till now, whatever you have designed, whatever you have found out the values, okay, your hn of s, which is equal to 1 by bn of s, which is nothing but your what? 1 divided by product of s minus sk, where your k varies from 0 to 2n minus 1, and you're going to choose only LHP left half of the S-planes, you always write LHP here, which means only the left half of the poles you're going to choose. Okay, these are the things that you have. This is your, this is nothing but your Hn of S. So your Hn of S is like this. Whatever you have designed until now is this. Now the next step is how to do the transformation. For that, you have to refer to the transformation table, which I will give you. Okay. So by then, now if you complete so much, what have you done? You have reached, you have, say you are ready to do the analog design of the filter by now. Okay, you're ready to do the analog design of the filter. Okay, the calculations of Butterworth polynomial, all of you please do it, complete that table. Okay. All right. So,
Ma'am,
yes,
ma'am, when n value is given, we need to calculate that transform that we found, no, ma'am, s plus 1, all those values,
yes,
bn
yes.
values that we need to calculate, ma'am, if
Yes,
problem is given.
yes, you have to calculate, or if it is still the values of phi, you can remember in this table. And remember this table if you want, or else you can, whenever you want, you can calculate these. At least 1, 2, and 3 and all you can remember, no? S square plus root 2 s plus 1. As you solve more problems, you yourself will remember these values. Okay, so, or else you do it, I mean, then and there itself you do it fast. You practice this and write it, so till n equal to 5, 6, 7, till how much ever possible you can solve it and keep in your notes, so that it will be in handy with you. And even if you do not know, like in the exam, if you don't remember the Hn of S equation, you can then and there itself, you can, by whatever I have shown you now in these steps, by these methods, so n equal to 1, s minus s naught, you know it is s plus 1 you will get. So similarly, h2 of s, okay? Similarly, or h2 of s, h3 of s, h2 of s, we saw root 2 s square plus root 2 s plus 1, how we got it, right? So substitute like this and find out, choose the left half S plane and quickly do it. You can do it in the side, all this whatever I've shown you till now. Okay. So in the exam, if they ask you this much, you have to do it. These things you must know thoroughly. We have not yet come to the question. We have not come to the problem yet. How to, if a high pass filter is given or anything else is given, right? How to solve it, we have not yet come to that. So I think for the next class also, you please, I will send the same link to sir, so that you can join in the same link itself. One second. All right. So now we have not yet, what I was saying is, we have not yet reached the problems. The specifications are not yet given to you. So this is one part of the problem. How, if they ask you to design a high pass filter or band pass filter, or band stop filter, then what is the transformation you need to do? I will send you that table. There's one table. I'll send you that. You please write down that and keep. It's there in your notes also. You can write the table and keep it. Okay. You must refer to that accordingly. We will do it. I can just tell you one. For example, if you want to design, say, a high pass filter is asked to design. Okay. And you will first design your value, your Hn of S. Okay. It looks something like this. You are going to design what? You will design your low pass filter first. It will have some specifications. Say the magnitude in dB, log 1 is 0. In magnitude in dB, this is, if it's a unit filter or your h of j omega, since you're considering a normalized filter and the magnitude of unit magnitude, if you take the log 1, it is 0. So in the log scale, I will write the x-axis. This is nothing but your 20 log of h of j omega. Okay. And say you have a particular Kp value. The Kp value will be there on the x-axis. Another value that will be given, if it is given in dB, the Ks. Kp and Ks is what? The gain values, if you remember. Remember this? We need to go back, right? Yeah, here. Remember, I had told you, no matter what, in dB, the gain will be given to you in the question. Kp is nothing but 20 log of 1 minus delta P. Ks is 20 log of delta S. So in your problems, this is how it is going to be specified. Right? In your problem, this is how it is going to be specified. Kp and Ks values will be given in the question. You will design it for, what are you designing? From the Kp, if you drop down, your cutoff frequency is 1. For 1 radians, you would have designed the filter. This is your stop band value, omega S. So this is your low pass filter, Hn of S, which you will design first. Now, you should apply low pass to high pass transformation. For applying this, how should it look? You are going to replace, wherever there is S, you will replace it with omega u by S. Okay, this is your low pass to high pass transformation. This is there in the table. I'll give you that. Okay, so when you do this, your high pass filter response is going to look like this. This is your high pass filter. High pass filter will look like this for the same specifications: 0, some Kp and Ks, right? So here your Ks value, you can see this is your omega S, and say this is the value of your omega u. Omega u is the new value of your cutoff frequency which you're going to consider. So your omega S is equal to the backward design equation. So this is called as backward design equation, what I'm writing now. Omega S is equal to omega u by omega S dash. Okay, I'll tell you what is this and how to do it. But after designing your low pass filter, you will apply some, this is your transformation that you're going to replace. In the Hn of S, you will replace this equation and you will rewrite your high pass filter graph, and you will, the backward difference equation, this is your backward difference equation. So similarly, you have your band pass filter, band stop filter, and even low pass filter. Even for low pass filter, low pass to low pass transformation you need to apply. Okay. So we have, if you have understood this, okay, even for your, what is that, for your band pass filter and band stop filter and all that, the table you please, I will send it now itself. You copy it down in your notes. Okay. And there is one more thing, that in the question, they will not mention they are not going to mention to you the order of the filter. Okay. So you will have to find out the order of the filter. There's a small derivation for that. Okay. How to find the order of the filter. There's one expression we'll get. We'll arrive at that expression and then we'll be ready to solve the problems. Okay. We'll be ready to solve the problems if we know two more things we need to know. What are the two more things? Two more things we need to know to solve analog filter design. What are those? One is, what is the order of the filter? Expression for the order of the filter, and what is the expression for the cutoff frequency? Suppose a cutoff frequency is given, or if it is not given, how to calculate the cutoff frequency, how to calculate the order of the filter. Are you getting? So this is what we have to find out. So let us at least start off to do the derivation. Okay. So we will take up a design of low pass Butterworth filter and we will try to obtain the expression for n, or if possible I will make the recording of this and I will put it, because let's not waste time in just doing the derivation alone. Derivation could be asked in the exam also. I'll give you the this thing for this. Okay. What is the time? It's 9:50 already. Will we be able to finish? I'm not sure. We start off. So if we are done with this, right, we will be able to, you know, do the problem correctly. Start doing the problem. At least analog design, we can start doing the problems. Okay. Fine, then I will stop it and I will, you know, start the meeting all over again. You join for your HDL class using the same link. I'll make Vikas, Ananya, Akshaya, I will make you the co-host. You can keep adding people also. Okay. I'll send you this on WhatsApp. You please, you know, write down in your notes. Okay, analog to analog transformation. Okay, I think we'll end the meeting then. And we will start. I'll restart the meeting. Any doubts you have, students? You want to ask anything? No? There are more things that we need to finish actually. I wish I could get more class. Somebody has told at 9:44. Yeah, I can share the notes. What is there on the smart board, I will share it with you. Don't worry. Okay? Not an issue. I'll share it. Whatever I'm writing on the smart board, I will share it with you. Don't worry about it. All right. Or even the table, I will, after the class, I'll draw it in the smart board itself along with this notes and I will send it to you. That's also fine for me. Anything else, students, you want to ask? No?
Ma'am, is the third internal is offline, no?
It could be offline. So you better start studying. There is no, we have not yet reached a conclusion on that. Could be online also, we never know. But as of now, for fourth semester, since there is still time, okay, maybe there are chances. So start studying at least the last unit, fifth module, and this module also we will include. So all of you, please keep up the pace and start studying the things. Okay. Fine. Fine, then we'll wind up. You please rejoin the same meeting. Sir will also join here itself.